Hi, in this video we're going to be looking at how to sort an array in ascending order using the MergeSort algorithm in C#. Okay, so I've already went ahead and prepared an array. Here you can see the array of integers that are arranged in random order, right? So we want to sort this such that the array is sorted in ascending order from smallest to biggest. Okay, let's get started. So firstly, we're going to create a function. Let's call this function MergeSort. It's going to take in an array of integers. Alright, so what we want here is to split the list in half, right? So in order to split the list in half, we're going to need the length, or rather the number of elements of the left half of the list and the number of elements of the right half of the list, right? Okay, so how we go about doing that is we're going to say int left length is equals to the total number of elements in the array divided by 2, right? So this will give us the number of elements of the left half of the array, right? So if for instance this was half, right? If this was half, then the left part would contain at least 3 numbers, right? Okay, so now we want to do the same for the remaining elements, right? So to get the number of the remaining elements, we would say int right length is equals to the total number of elements in the array, which is array.length, minus the total number of the left elements in the array, right? So this now has effectively given us the number of elements of the left half of the array and number of elements of the right half of the array. Sorry. Right. Okay. Now we need a container to store the elements of the left half of the array and another container to store the elements of the right half of the array. So we're going to therefore define 2 arrays. One, we call it the left array, which is going to contain elements of number left length, right? So it's going to contain elements that are of size of the number of elements of the left half of the array. So inside this array will be left length numbers of integers here. So this will be the size of this left array. Now we also define the right array, which will contain the right length, right number of elements of the right array, right? So these are just containers. This is a container for the left half elements, right? This is a container for the left half elements of the array, which is why we passed in the number of elements of the left half of the array. And here, this will be the container for the right half elements. Right. Okay, so now that we've created these containers and we've also retrieved the number of elements of the left half of the array and the number of elements of the right half of the array, it's time to actually split the array in half. So if we want to split the array in half, we have to say array dot copy right? So we're copying the original array, which is array, and then we want to start at index 0, and we want to copy this array firstly into the left array, right? Which means we're only taking the left half for now, and then we want to start at 0, right? We're going to store this element starting at 0 of the left array, right? We're going to start at the 0th index of this left array, right? And we know that the total number of elements in the left array would be left length. Okay, so this line alone just takes only the left half of the original array. So it takes only the left half of this array and then stores it in the left array, starting at index 0, right? And storing it also starting at index 0 up till the left length. So we then do this again, but now we're copying the remaining elements, which means the right half, right? We're starting by specifying the original array in which we're taking the elements from, and then we start, this time we can't start at index 0 because remember we're copying the remaining elements. So remember that on this first line right here we ended at left length, right? So we still need to start at left length here. We're going to start from left length, right? And we're going to copy the elements into the right array this time, right? And in this right array, since the right array is empty, we're going to start at index 0, and then we put in the total number of elements that are left, which is right length, right? So now we've effectively split the left, we've effectively separated the list into two halves, right? Which is the left half and the right half, right? So this is what these two lines do. They take the original array, right? And what they do is, okay, so starting at index 0 here, we take 7 up till the middle, right? So if the middle is 5, then we're going to take these values here, 7, 1, 8, right? And then store it in the left array, right? And then we start from where we ended, right? So if we ended at left length, which means maybe if we ended at 5 at this position right here, then we're gonna then take the elements from 5 till the end and then copy it into the right array, right? We're gonna copy it into the right array, right? Starting at index 0 because the right array is empty up till the end of all the elements, right? So this is what these two lines do. Now once we're done with that, we need to further split the list in halves as well. So we need to further split the left array into its own half and the right array into its own half as well. So we're going to continue to do that. So we're going to split the array that we get in half. We also split those two halves into their own halves as well, and so on and so on. So we're going to say merge sort, split the left array as well into its own halves, merge sort, split the right array as well into their own halves as well. Okay, but this can go on forever, but remember that the list is finite, right? So eventually we will reach a point where there's only one element in the list, right? So eventually reach a point where there's only one element in the list. When that case is reached, we want to then break out of this loop that we're creating, right? So this is essentially a loop called a recursive loop, right? Where a function calls itself over and over and over and over and over and over again, right? Once a certain condition is reached. So this is the condition that we're going to put here. So remember that this list will be called over and over and over again until only one element is left, where you can no longer split the array into two arrays because there's only just one array left. I mean, there's only just one element in the array left, right? So let's write that. We're gonna say if there's only one element in the array left, which means the array is now less than 2, right? Then just return, right? So this will effectively break the loop. Okay, so now that we've split the array in half up until this point is reached, now what, right? So we now need to combine the list back, right? So you might wonder, okay, so we just separated the list. Why are we combining it now? Why are we putting it together again, right? Wouldn't that just be like, well, it's essentially a dumb thing to do. You know, you split the list in order to put it back together again, right? It seems pointless. But the key in putting the list back together is in actually looking at the values that you're putting together and then rearranging them in sorted order, right? So if we're putting 1 and 2 together, right, you will obviously put them together in such a way that 1 is assigned to the first index, right, and then 2 is assigned to the second index, right? So for instance, if now I have a list as 2 and another list as 1, right? So this 2, I'm trying to put these 2 together, right? So if I'm putting these 2 together, I'm obviously going to take 1 first and put it here like so. It's going to be 1 and then I put 2 after. You see, so now I've combined these 2 separate arrays into one array, but then whilst I was doing that, I made sure that 1 receives the lowest index, right, which is index 0, right, and then 2 receives the second index, right? So as you can see, we're gonna do this, but for a larger list, even for a larger list, if you have now 2 and 3 and 1 and 4 here, right, so if you were to combine these 2 lists, you obviously prioritize the smallest numbers first, which means it's gonna be 1, right, and then you're gonna take 2 and then 3 and then 4, right? So this is the key to putting the lists together, is that you have to sort them before you put them together, right? So let's just do that. Enough talk, let's just do that. So we're gonna go here at the bottom and define a function. We can just say sort array. Sort arrays. Okay, so the sort array is going to take in an array, right? And it's going to take in, this is going to take in an array to store the sorted array, right? Or we can even say sorted array, right? And then we can say here left array, and then here we're gonna say right array, right? So I don't know why I write that way. Okay, right array. Okay, so this function takes in the sorted array, right? This is where we're going to store all our sorted array. This is where we're going to store the sorted array, and then here this is the left part that we need to merge with the right part, right? So firstly, we need a way to index these arrays. So we're going to define a few integers. So we're going to say int I equals 0, int j equals 0, int k equals 0. Okay, so this is just a way for us to index our arrays, right? So these are just letters we're going to use to index our arrays. Okay, so even in fact we can just say this is for the left array, so we can just say L, and this is for the right array. This index is for the sorted array, right? So to make things a little bit more simpler. Okay, so what are we going to do now? We're going to check. We're going to say while the left index is less than, right, the left array dot length, and the right index is less than the right array dot length, right? Do what? Compare the values in the left array with the values in the right array to see which one is smaller, and then put that value first in the sorted array. That is exactly what we're going to do. We're going to say, okay, if the left array, right, if the left array then index L, right, is less than or equals to the right array at index right R. Right. So what this line compares is the elements at index L, which currently is 0, and the elements at index R, which currently is 0. So they're comparing the first elements of the two arrays, right? So they're saying, okay, so which one is smaller in the first element, right, in the first index, right, of these two arrays? Which element is smaller, right? Is it the one on the left array or the one on the right array? So if it's the one on the left array, then that means that we're going to take the element on the left array first and store it in the sorted array. So you're going to say sorted array S, right, for the S index, for the sorted array index S, right, this index, right, and then obviously we need to increment this index now because we're storing a value in the index, so we don't want to rewrite the value, so we need to increment the index once we store the value. And you're gonna say left element, because left array, because now we thought that, okay, this condition was true where the left array had a smaller element, right? So and then we say L plus plus, right, and we increase. Now we increase the L element as well, because now that we've used this index value, we now need to increase the L as well, right? So this is the case where the left array contains the smallest element. But what if the right array contains the smallest element? Then we can just say else, right? Because obviously if this is not true, then the other statement is true. If this is not true, then the opposite is true. The opposite being that the right array is the one that contains the smallest element. So we're gonna say sorted array, right? Sorted array S plus plus is right array R plus plus. Okay, now this loop right here is the one that actually sorts the array, right? So it checks the elements in the left array against the element in the right array, right? If the element in the left array is smallest, then we put the element in the sorted array. Otherwise, we put the other element in the sorted array, right? And then we increase the indexes as we're doing here. Okay, so now obviously there might be some elements left in one or the other array after sorting is completed in this while loop, right? So if that's the case, right, then we want to make sure that all the elements are added in the sorted array. So we're gonna say while there's still elements left in the left array, right, while L is less than the number of elements in the left array, right? So this just checks if there are still elements left in the left array after this process is complete, right? After this process is complete, we need to check if there are any more elements left in the left array to be put into the sorted array. So you're gonna say sorted array S plus plus is assigned to the left array L plus plus, right? Also, we need to make sure that, because it might be that all the elements in the left array are used up, but then elements in the right array are still remaining, right? So we still have elements in the right array as well. Then we might also have to check that while elements in the right array right, we're gonna say sorted S plus plus, assign it to right array R plus plus, and then we are finished, right? We are finished. So this function combines the two parts, right, into a single sorted part, right? So this is what we're doing there. Okay, now let's just review what we did. So we defined a function called MergeSort, and we said that this function actually splits the array, the given array, into two halves, right? And those two halves are further splits into their own halves, right? And then after that, after the splitting occurs multiple times, which is why we call the MergeSort function over and over, we've eventually reached a point where we can no longer split a list because now there's only one element left in the array, right? Then we return. Now we said that we also have to now combine the halves, right? We also now have to combine the halves, so we need to call this function here, sort array, right, which will take in the original array and then the left half and then the right half, right? Okay, so what happens here is that an array will be passed into this function, and then this array will be split into two halves, right? The left half and the right half, which will further be split into their own halves as well, and then those halves will then be combined, but then they will be combined sorted. That's why we call this merge sort, right? So you split the array in half and then combine those halves, but they have to be sorted when they're combined. Okay, that's it. This is the merge sort algorithm. Now let us see if we succeeded. Okay, so what we're going to do first, we're going to say console the right. Okay, let's just say right, and I'm going to say before sorting, right? And then we're going to say console dot right after sorting right. So we need a function to print the array so that we don't use two loops, so we just use one loop and just recall the function. So we're going to say print array, right? So we need an array to print, obviously, so we're going to say int array, right? And we need a for loop. Okay, and then we need to say array the length, all right, and then we print the array elements, array at index I, and then space. Okay, and then we print an additional line to go to the next line. Alright, so this is just a helper function to print an array, right? So let's now say, okay, before sorting we want to actually print the array. So we see that the array is not sorted, so we're just going to say print nums, and then we're going to say after sorting, which means we then have to actually call the merge sort algorithm here. We're going to say sort, therefore we call the merge sort algorithm here, pass in nums, right? And then print the array again, but now this is after calling merge sort. So we print the array passing in nums. Okay, now we just cross our fingers and hope that everything works. Okay, so we're gonna say .NET run and we have our sorted array. You see, we have before sorting, and then this is after sorting. You can see now the list starts from 0, 1, 2, 5, 6, 7, 8, right? This is the list before sorting, and this is the list after sorting. Okay, perfect. That's it. Right. So thanks for watching. I know this seems long, but go through it again, and again, and then you'll see that it's really simple. Please like and subscribe.